Hello, my name is Andrew Pearson, and today I will be going over the flyweight pattern. The intent of the flyweight pattern is to use sharing to support a large number of fine-grained objects efficiently. The motivation behind this pattern is typically used when objects become too expensive on their own. So like if you're creating a lot of different objects for say like a menu or a car company, and you have a lot of different cars being purchased with different owners, and you can make an object that is a shared state that can reduce the cost of the objects that you create. And then those can be reused for each unique object. The applicability, the flyweight pattern's effectiveness depends heavily on how and where it's used. Apply the flyweight pattern when all of the following are true. An application uses a large number of objects. Storage costs are high because of the sheer quantity of objects. Most object states can be made intrinsic. Many groups of objects may be replaced by relatively few shared objects once intrinsic state is removed. The application doesn't depend on object identity. Since flyweight objects may be shared, identity tests will return true for conceptually distinct objects. So this is an example of the general class diagram. You can see how each interacts with each other. The client controls the flyweight factory and accesses the unshared concrete flyweight and the concrete flyweight. And then the flyweight factory interacts with the flyweight to create that state. So the participants in the flyweight factory are the flyweight. It declares an interface through which flyweights can receive and act on intrinsic states. The concrete flyweight, which is the character, implements the flyweight interface and adds storage for the intrinsic state if any is required. A concrete flyweight object must be shareable. Any state it stores must be intrinsic. That is, it must be dependent on the concrete flyweight object's context. Unshared concrete flyweight in rows and columns. Not all flyweight subclasses need to be shared. The flyweight interface enables sharing it. It doesn't enforce it though. It's common for unshared concrete flyweight objects to have concrete objects as children at some level in the concrete object or in the flyweight object structure as the row and column classes have. The flyweight factory, which creates and manages flyweight objects, ensures that flyweights are shared properly. When a client requests a flyweight, the flyweight factory object supplies an existing instance or creates one if none exist. And then the client, which maintains a reference to flyweights and computes or stores the intrinsic states of the flyweights. The consequences of this design pattern are the flyweight may introduce runtime costs associated with transferring, finding, and or computing intrinsic states, especially if it was formerly stored as intrinsic state. However, such costs are offset by space savings, which increase as more flyweights are shared. Storage savings are a function of several factors. The reduction in the total number of instances that come from sharing, the amount of intrinsic states per object, and whether the extrinsic state is computed or stored. So you supplement some runtime costs for the space you're saving. So here's my example class diagram. You can see I have the flyweight factory, and my unique state and my shared state. I didn't use an unshared flyweight for this one. It wasn't necessary, but that is something to keep in mind that you can use. It's time for the demo. All right. So here in Visual Studio, I wrote a C++ program for this flyweight that is designed for a coffee shop. So you can see we have our shared state here with the fields string double, with the fields size, price, and type. We have our shared state, our initializer, our constructor, and the OF, the operator, to output it in a certain format. And then our unique state is a similar struct, which has the customer and the order number. So these will all be unique. The shared state will not. Then we have our flyweight, which is the actual shared state. So it will display the shared state. It'll return the shared state. It's how you access that shared state. Then we have the flyweight factory, which manages the flyweights in an unordered map. And then you have the keys, which is these are the shared states. Then you have your flyweight factory, which is the constructor for the class. The get flyweight, which checks to see if you have that created or not, that shared state created or not. If not, it creates it. But if you do have it, it will notify that you have that shared state and it'll return it. And then you have displayed menu, which displays the map up here, which has the unique state and the shared state in it as well with each of those paired. And then we have our client right here, which is a create order. So you can see we have customer placing an order and then it accesses the flyweight. It gets the size, price, and type of the flyweight using get flyweight. And then you have the flyweight operation, which is customer and order number. That's the output for that unique state as well. So in our main, we initialize kind of a base menu per se, because it is a coffee shop. So we have in our flyweight factory, we have 3 different types of black coffee, 3 different sizes of lattes, and 3 different sizes of cappuccinos with different prices. So those will be our shared states that can be ordered. So you can see create order takes in menu, the size, the price, the type of coffee, the name of the customer, and what order number they are. So this one should be available. The shared state should be available. And then the next one is an order that the menu does not have. It would be an iced latte. So you'll see when I run the program that it does not have it, so it creates that. And then we have 2 different display menus. This will display the initial menu, and this will display the menu with the added item. So let's run this program and see it work. So you can see our original menu has 9 items. So you can see the order we put it in is the order that it outputs. So you have the small, medium, and large black coffee with the prices there. The small, medium, and large cappuccinos with the prices there. And the small, medium, and large lattes with the prices there. The orders are a little mixed up. Not really sure why it does that, but let's keep moving on. You can see that with that first one, customer placing an order, the flyweight factory returns that the menu item is found, meaning we already have the shared state in there, so we don't have to make a new one. And then we display the order using the flyweight, the small price, $2.99, black coffee, and then the unique state, John Doe, order number 1. Okay, then we move on to our next one, placing an order, flyweight factory. It cannot find the menu item, so it creates a new one. So then we see flyweight factory display the order, medium, the price $4.29, and then an iced latte, and then the unique state, Jane Doe, order number 3. So now we go back here when we display the new menu items 10 instead of 9. And then if you go down to the bottom, you can see we have an iced latte medium at $4.29. We could keep adding menu items to our menu as many as we wanted to, and those will be our shared state. So as long as it's in there, you can keep reusing them, and it won't take as much space as if you were to make individual objects for it every single time. So just in case, I have the example code right here and there, and then I have my resources that I used, the textbook, and then the refactoring .guru, very helpful website. And that is all. Thank you for watching.